Everyone. I'm Andrey. I'm a software engineer at Apple, and also I'm the AutoML training coach here. So before I start, I just want to say huge thank you to Amber, Josh, and Matthew for organizing this, because I think it is very important, like as you mentioned, to have a one time a year to meet all the folks, especially users, contributors, and people who are actually interested in ML space, and we need to be close with our users and with contributors on such of these events. Yeah, so I think today we just give you a few updates from the AutoML training side. So, Johnu, do you also want to introduce yourself?
Hi everyone. I'm Johnu, staff engineer at Nutanix. I'm co-chair of training at AutoML. Um, Talking about myself, I'm contributing to Qflow since very start. I'm very excited to see how people bet on Qflow and how people are having Qflow in their on-premise and the cloud deployments. So we can start. Andrey, can we get to the next slide, please? Sure. So just talking from a training operator point of view, so very brief intro. So this was one of the very early component that Qflow had. So in fact, this is the first component that we had in Qflow. Started with a TF operator, the TensorFlow operator, then followed by PyTorch, XGBoost, and so on. So right now it supports almost all popular frameworks, XGBoost, MXNet, Paddle, and all of that. So it has lots of great features that makes it production ready. It is being used in production in various companies and a very mature framework. So it handles distributed training of all various jobs, yeah, whether it is TensorFlow, PyTorch, or like any other framework, right? And it supports all reduced style training using MPI or Horvath. It has support for various job scheduling plugins. Right now we have added, I'll talk about it regarding the scheduler plugin support that we have added. And specifically for PyTorch, the elastic training is supported. So you could specify minimum and maximum replicas that are allowed for a particular job. And then if you want, even you can set horizontal pod autoscaler based on certain metrics. So this is particularly useful for cloud deployments where you want to save resources and save on cost while training, right? Because it can use your spot instances or something like that on your cloud environment. And we have, in order to interact with training operator, we have SDKs and APIs. So from a data scientist point of view, they could directly use SDK without knowing anything about your underlying infrastructure. Yeah. Next, please. So from 1.7 point of view, so one of the major thing that we have done is merging the Qflow common repository to the training operator. So just to give a context, earlier, so when we started training operator, most of the operators were kind of like separate. So we had separate repositories for TensorFlow, PyTorch, and others. And it was getting difficult to manage everything. So we tried to bring a common framework that can host all common features, and individual training operators just do their part, right? And over time, that also became bigger and bigger. And we decided that we will actually get a unified training operator, which is the current state. So we have a single training operator which can handle all the frameworks right now. So there is no requirement for having a separate common framework, which we had earlier. So we are trying to merge it back. And since it was a separate common operator, one side effect, separate common frameworks, there was a side effect that there were lots of inconsistencies between frameworks. So having it merged back to the training operator, now we are trying to clean up various minor inconsistencies between the frameworks. And the other major feature that got added was the suspend semantics. Right now, you could suspend the training operator, the training job for various frameworks. So if something is being run and if you set a suspend flag, the active pods will get deleted and it goes to the dormant state, right? And you can resume it back later. And if it is just started, it won't start creating more pods after that, right? And if framework support it, you could basically restart from the previous checkpoint point as well, like based on the framework support. And one important feature that we have added is the multi-GPU support per process. So earlier, like if you think about PyTorch, we were supporting DDP by having one GPU per container. So if we had 8 containers, you would need 8 separate containers having like one GPUs each. So that is, and over time, we realized that that is adding extra performance overhead. In particularly like in a single system, when you have like 8 GPUs, it is not performing enough. So we added support for having multi-GPU support in a single container, which is following the semantics of torch run. So in torch run, you could specifically say, I need X number of process per X number of GPUs per proc, right? And total number of processors. Right now it is aligned particularly to the torch run semantics. And this is particularly useful in the newer set of parallelism worlds, kind of like model parallelism or tensor parallelism, where you would need to do much larger parallelism when compared to the previous default data parallelism. We have added support for custom gang schedulers using scheduler plugin. So which means right now, if we have a custom scheduler, which follows pod groups, which is supported by scheduler plugins, you can just provide that name and it is automatically supported in the training operator. And we have added conformance tests as well for the training operator in the last release. So if you want to just check whether your environment is conformant enough for your for running various training jobs, you could run that. And we are yet to add for 1.8. So for till 1.7 we had that, and we will be adding support for 1.8 in coming weeks. Andrey, next. Yeah. So one major concern and recommendation that we got from community is still because earlier we were using primarily YAML files and it is not data science friendly. So we wanted that to be more data science friendly, and that is where we started adding data scientist friendly APIs. So from a data scientist point of view, it is not easy for them to create Docker files and build images before starting your distributed training jobs. So this is one of the first APIs that we have added for creating new training jobs by just providing the Python function that you want to do. So you just provide Python function as an argument, right? And provide minimal arguments in order to start the training job, and it automatically takes care of it. Creating the right YAML files and applying that to Kubernetes. So we are trying to get to a world where data scientist and the infra layer is completely isolated, and we are just in the start. And over time, we will actually add more and more APIs that would help data scientists to work directly from notebook without knowing anything about Kubernetes. So we are not there yet, but again, this is like one of the great start that we had. So I just want to bring the LLM side of it as well to the community. And Josh briefly talked about it. And there were lots of conversations in the community before this as well. And Roblox also talked about it. So just want to talk about the LLM specifically. So if you think about the newer buzz is around the generative AI or the LLMs, right? And people will obviously get a question, what is it so different from the other deep learning models, right? Now, the problem is it has become so huge and your traditional methods won't work. So and that is the reason that like there are more and pretty huge number of frameworks which are specifically set up for various requirements for LLM. That whether it is in the training side or whether it is in the serving side, because the challenges are quite different. So in a typical LLM workflow, people have kind of like custom data with them. They want to fine tune on the custom data, or they want to do a full pre-training from scratch on the custom LLM that they have, right? So once they get to a point, they want to do some kind of like hyperparameter optimization, because there are lots of hyperparameters in the LLM side, but in kind of like top E and all other things, right? And then once you have got a tuned and optimized model, we can just put that for the serving part. Again, there are specific frameworks right now which can take advantages of transformer based models, and they are quite popular, that we are planning to invest. Next, please. So having seen the LLM side of things, so if you remember the Qflow vision, right? One of the earlier customer user journey that um, we had very similar workflow, right? User starts from Jupyter Notebook by by adding code. They build and they train. They get to a point where they see a basic model. Then they are ready to get to a much larger set of things by doing distributed training across multiple clusters or multiple nodes. So they get a trained model. Then they tune these models yeah, using some kind of hyperparameter optimization. They get the tuned model and then they serve, right? And this was one of the core principles of Qflow, which we have been talking for last 5 years. And we are like even in the LLM space, it is something very, very similar that I have talked before. So how can Qflow get into this, right? And how can we provide specific solutions for LLM as well? And if you think about it, we have training operator for which can handle various needs for the training side, which can do fine tuning and pre-training, followed by the tuning side, which can be done using Catir. The serving can be done using Kserve, and the whole ML workflow can be orchestrated using Kubeflow pipelines. So we have a solid base here. So it is just that we have to provide the right wrappers and layers on top of it to make it efficient for specific LLM models. So that's where one roadmap, what we achieve in the LLM space, and we would like community also to contribute. And if you have questions, like we are happy to talk about. And this is like one of the the near items that we want to solve, right? So particularly when you think about the training side of it, you would take there is very less chance that people start creating a new model altogether, right? And they are free to do so. But again, the most common use case is they take some base model, which is hosted in a repository, maybe like Hugging Face or like some external repository. So that's a base model that they take care of it. And then you have some custom data set, which is in PVC or like some external storage, right? So you provide model, you provide data set, you provide GPUs, and say that I want training or a fine tuning on top of that. And you get your trained model on a particular output location that you provide. So once it is done using training operator in a very highly distributed manner, taking advantages of all parallelisms which are possible, you could use that in Catir for the hyperparameter optimization. Set objectives and parameters that we want to tune, and we get a tuned model out of that. And if you see that the top layer, it is all data science friendly APIs, right? Like using SDKs, we provide APIs for data scientists to directly interact with the training side without knowing anything about the underlying Kubernetes SDK. And finally, once you have a tuned model, we put that into serving by providing the storage URI in Kserve. And the whole thing can be automated using Kubeflow pipelines. So this is something that we are very much interested, and we are hoping to see some solid results in 1.9, and in coming 1 to 2 weeks, we'll have a proposal in the community regarding this. So just talking about the major items in the roadmap, the same things that we have talked about, the pre-training and fine-tuning part in training operator. We are also trying to see, can we do something specifically about the data accessing part, right? So when you have a larger model or a larger data set sitting in some PVC, the problem is each worker which is started separately will have to load it separately. So say you have 15 gig or 30 gig of model sitting somewhere, it is not easy for every worker to load at the same time, even before starting the model, right? Starting the training process. So we are trying to see how can we optimize that area. That is one key research topic that we are looking at. and quick access to various foundation models sitting somewhere in external repository, kind of like Hugging Face or Docker Hub or somewhere else. And we have an issue created. You can comment on that, and then we'll have a proposal, and I'll send that link to the community very soon. And we had MPA operator V1 in the current release. So we had a separate operator V2, which we migrated. Right now, it is in a separate repository. We want to get it in training operator as well. So we are having a discussion whether to keep it separate or part of the training operator. So that's something that we are constantly looking at. And one other recommendation that we got from community is if we can have a very minimal UI, like in the central dashboard, particularly when we have APIs which are data science friendly, we could add these fields that can be invoked from UI itself to start the training job. But for really advanced use cases, they have to still rely on YAML. And that's the same thing that is followed by KServe also. And there's a discussion about the Spark operator in the community. So please look at the issue there. We have solid feedback regarding that, and people are interested. So we would like to have more contributions regarding the Spark operator also for the data pre-processing part. So this is particularly useful for various data pre-processing, where we can get the pre-processed output directly to the training pipeline. So we are looking at that aspect as well.
So
that's all from my side.
Yeah.
Thanks, Andrey.
Now if we can switch, or I can just speak about. Yeah, can I continue to speak? All right. Yeah, thank you, Johnu. Yeah, so I think as Johnu mentioned, our main focus right now, simplify data science access to Kubeflow, giving them the ability to do something more with large models, and streamline this experience for many users who actually use Kubeflow every day. So just to remind you, this is the architecture of what KDIP looks like, and from the initial look, it exactly the same. Has exactly the same patterns was what training operator has, right? So KDIP is a project which basically connects different optimization libraries to Kubernetes clusters. And basically for this purpose, KDIP has its own Python SDK, its own web UI and API level access, and provide additional functionalities to run all these features on top of Kubernetes natively. For example, HyperM tuning, right? All these frameworks like HyperOpt, Aptuna, scikit-learn, they have their own optimization algorithms, and we try to have interfaces between them and Kubernetes clusters. So by doing this, users can do HyperM tuning, users can do neural architecture search, so even search for the best architecture. Also, we have some ability to do some early stopping to help you to avoid model overfitting, save compute resources, and do optimization even better on Kubernetes cluster. And as I mentioned, since we have web UI, we have an ability to track your metrics and do some workflow orchestration. So for all these things, it provides you the great foundation to tune a model, especially on the large scale of LLM and different things. So speaking about what we did for 0.15. So right now for Kubeflow 1.8, we're releasing KDIP 0.15. And I think one of the major feature was to migrate to the new KDIP config API, and I'm going to speak about it in the next slide. Basically, which provides user an ability to much easier to set up the KDIP configuration and having more control over your algorithms or controller parameters. Also, we support failure policy to fail, which significantly improve debug purposes for KDIP, because we heard from many users that right now it's very hard for them to understand how a webhook works. So by doing this, it's very easy right now to debug things. Also, with these new KDIP API, we consolidating CR generator to controller, which means if you want to use KDIP as independent component, you don't need to install CR generator. You just can run one single command, and controller will do everything for you. And similar to training operator, we try to build this conformance test for people who want to use Kubeflow and the whole umbrella of projects. So basically, it gives you an ability to run KDIP in production much easier and be conformant with the Kubeflow components. Also, we currently, similar to training operator, we improve SDK to give you an ability to set the resources like GPUs, CPUs, TPUs, in a very kind of data scientist friendly manner, and I'm going to speak about it also in the next slides. And we got continuing improving the API in recent years. So right now we have even given ability to actually check the trial logs on the UI without switching to Kubernetes. So again, the main thing here, we try to simplify deployment and give you the more access to Kubernetes compute. So this is the example how the new KDB config API looks like. So it might be hard to to consume all of the parameters. But basically the main thing here to understand that you have the one entity which called KDB config, and basically in this config you can specify literally anything for your settings. For example, you can specify the webhook port, or what kind of resources you can consume in KDB, what kind of parameters you have for your certificate generator. And you also have some runtime parameters like metrics collector or suggestions or early stopping. So we kind of split them between init and runtime, which gives the user an ability to understand what kind of parameters will be fetched during the runtime, or the parameters to which can be set only when the controller starts. So it's much easier for users to maintain it, and for actually cluster operators to control the environment without knowing about all of the components of KDB. So similar to training operator, as I mentioned before, our main focus in this year and the next year, just to simplify ML experience. We want to give you a very simple API to tune your models very fast without know anything about Kubernetes, Docker, YAMLs, all these kind of buzzy words that data scientists doesn't need to know about, because they want to do science. They don't want to do DevOps engineering. So for this particular example, right now you can easily define a model in the train model API. And if you know TensorFlow, this is just pure TensorFlow code where you just say model.fit with number of epochs. And from the KDB side, what do you need to do to tune your hyperparameters? We have this kind of new tune API where you say, I have this job, I have this objective, and I want to optimize number of epochs with this distribution. So KDB.search allows you to set the minimum and maximum value, and also, since we want to support more kind of distributed strategies, you can also basically specify, maybe it will be log uniform parameters. So very similar to what does that data scientists actually know about, right? Also, you can say how many trials you want to run, how many resources you want to consume, and what kind of objective you want to optimize. And similar in the same environment, you can get your results from your tuning experiments. So you don't need to jump to kubectl. You can just call get optimal hyperparameters and consumer metrics in your Jupyter notebooks. So which gives you the foundation to the kind of give you quick access to the whole kind of Kubernetes API from your notebook or from your VS Code without knowing about YAMLs, right? So, and this is what we can do even right now. So right now, many data scientists, they love Jupyter and they want to work Jupyter and they don't want to leave Jupyter. So basically, they want to just start a notebook. They want to code that training, and they want to specify number of GPUs, number of workers. And then they just start this job, and the job will basically distribute your training across multiple workers and do additional kind of things to run this on Kubernetes and access to the jobs for the user. So user only interact inside Jupyter and doesn't need to worry about resource allocation or Kubernetes autoscaling setup, or basically how to set up your Kubernetes cluster, and be focusing only on the science, as I mentioned, not on the DevOps things. So in the FY23, we kind of looking for multiple things in KDB. Specifically, for many years, many users ask about support of multi-objective optimization. It's very common right now, especially in large models, and we want to optimize models with a different type of metrics, for example, loss and accuracy. And some of the optimization frameworks already support it, like Aptuna, where you support this multi-objective optimization. Also, we're looking forward to support more kind of parameter distributions like uniform, log uniform, which are very common across many hyperparameter tuning jobs, and we want to have the same in Kubeflow. Also, we continually see how we can have a better integration with Jupyter notebooks, because I think it is very important to have a kind of clear experience and very easy experience for the data scientists to have access to Kubeflow. And we continue to kind of improve this using the KDB SDK, the API, and other kind of interfaces for them. And we kind of have plans to release V1 version of KDB APIs And please, if you have any kind of feedback for us, let us know, because it is very important for us to understand what kind of features are missing and what kind of like APIs we want to see in V1 version of KT project. So just a little bit at the end, like I want to mention about the community. For us, it is very important to hear your feedback, especially from the users. We have our regular calls, so it's happening every 2 weeks in Europe and US friendly time zone. So please feel free to join these meetings. We have these kind of Slack channels for you to take a look and discuss different topics. And also, if you want to contribute, you can ping us in Slack, or you can also check this kind of developer guides that we have in Training Operator or KTIP. We have some help wanted issue label, like we can try to identify issues where we want to collect feedback. And if you want to have something to Qflow, please submit the proposal for us to the community. So with that, do we have time for questions? Maybe one or two, yeah. Maybe, yeah.
And then let people know they can find you
Yeah, absolutely, yeah. I will be in Slack channel, John. I think you also will be in Slack channel. So do you have one question from the audience that you want to ask? Or maybe from Slack?
You did such a great job. Everybody's like, they understand
Yeah.
it. No?
Yeah, go ahead, Josh.
So I think I heard
The likes of people
that
online.
we have optimization for GPU utilization.
Yep.
And I'm wondering, what are people doing without that? Like in other projects or other parts of Kubernetes workloads, stuff like that. Have we done something fairly unique here? Or are we catching up with other projects? Where are we with that comparatively?
So, Johnu, I think I can start and you can add your information. So I think the uniqueness, we kind of give a user the kind of like low entity in Kubernetes with which they can iterate. For example, we don't have Qflow clusters to run distributed training. We like similar to Spark, right? So in Spark was not built on top of Kubernetes natively, which means like if you want to run Spark on Kubernetes, you have to create your own clusters. You have to worry about multi-user isolation. You have to worry about like resource allocation, scheduling, other things. So from the training operator side, and KTIP also like has a similar patterns. We have like the low-level Kubernetes entity, which user can play with, which means like all of the user isolation is like built in-house because we kind of like follow in Kubernetes RBAC, which means it's very simple for kind of like, cluster the people who actually maintain these clusters set up the proper multi-isolation. That is why kind of like Qflow profiling controller exists. Also, it's very easy for us to integrate with different kind of scaling mechanism like Volcano, Unicorn, Q, because like it's like very low level entity that we have in Kubernetes cluster and we play with, right? So the whole Qflow components was natively built in Kubernetes, and that is why it gives us much more power to give user access to the resources. For example, GPU allocation. GPU allocation is much more effective to acquire in Qflow because we have a control over like what we actually deploy, right? So I think like it's kind of the differences here. Like all these like ML frameworks, TensorFlow, PyTorch, that they was not built to run Kubernetes. They was built on run on top of Python, right? And here it's like it's differences, like completely different layer of of how you submit these jobs. John, do you want to add something?
Yeah, I think you covered it. So I think just to add, right? So the advantage of particularly from a training operator perspective, as Andrey was saying, we are exposing full pod spec to the users, right? So either users have flexibility to use the entire pod spec to do whatever they want in the Kubernetes cluster, basically unlimited opportunities, or on the other end, if they just want a focused deployment, they can use SDKs for doing that. So here we have two different set of users, right? Either a pure data scientist who wants to actually isolate entirely from the Kubernetes space, while from the infra side, we really want how these training jobs are translated to the underlying infra, which Kubernetes provides awesome ways to actually handle that. And both can be done like when we become Kubernetes native, and that is the strongest point that we have.
Josh, does that answer your question?
That was great.
All
Yeah,
right.
thank you.
Thank you, guys. Thanks, John.
yeah, it's great to have this bridge between US and Bangalore, right?
That's awesome.
Yeah, absolutely. Thank you, Johnu.
Thanks, everyone. I want to thank Josh and Amber for taking all this pain to do this as well. Thanks, Amber and Josh, once again.
You're
Yeah,
welcome.
thank you.
Anytime.